green flash. Why are we interested in colors? Philip, do you know?
I actually don't know. Why are we interested in colors?
Because it's about today's experiment. It's about color, right? Come on in. So today we're doing, look here. Experiment 1, acid-base equilibria, buffers and indicators. Indicators are over here, right? There's not much color here, but under certain environment, there are colors, and we can do it together today. So for experiment 1 is acid-base equilibria, buffers and indicators. Essentially, there are only two little tasks you got to do. The first one is about checking color, okay? What it means is, right, you will just be taking your test tubes, adding chemicals, see the color, and put it on the table. See what color, okay? That's it, very simple. So to do that, remember, all your apparatus and glasswares are here. You take it from here. I took off the test tube rag and I put it here, right? Test tubes. Oh, over here, there's a Sharpie, okay? Because you need to label what chemicals going to your test tube. So for instance, you want to say, let me show you one example, okay, Philip? Our indicators here today we have nitrazine, Timer blue. Ooh, this is a base. Bromophenol blue. O cresophelin. And bromocresol green. So these are the indicators. Okay. So we try one. Okay, maybe Timer blue. Okay, shall we? Yeah, Timer blue. Timer blue. So and then we have got different pH. Okay. So I go like, okay, this is 0.1 m HCl. Okay, put here, and the next one will be pH 3. Next one will be pH 4. Next one will be pH 5. You see what I mean here? Very simple. Okay. So next step, you just have to add accordingly. So for the first case, you got 0.1 molar HCl, right? Do we have it here? Oh, you do. This is a secondary container. Always keep it inside here. Then you just take, okay, squeeze the rubber teeth. Make sure there's liquid there, it's not dripping, and then add. Okay, you see? When you squeeze one, this is about a ml that you need here. Okay, if you need a little bit more, just squeeze a bit more. Make sure your tip doesn't touch the test tube, no contamination. Okay, you see that? It's clear. And then you want to add Timer blue here. Make sure it's the right chemical. Okay, in this case, just a couple of drops. Okay, in fact, not more than 2 drops. So you see this one. Observe. Oops, you see, when it's not added inside here, it's on the walls of the glass. Ah, you see that? There's 1 drop. Just 1 more in case. Okay. Okay, not too much, huh? What's this color, Philip?
That's purplish.
Okay, put purplish. Okay, I think it's a bit more pink, but I'll put pink for me. Okay.
Okay, maybe I'm blind.
No. The singer, her songs are good. Okay, so here we go. Put down. Next, we got buffer pH 3. Okay, let me see. Buffer pH 3. So squeeze the rubber teeth and put it in. Okay, just a bit more. Okay, no touching. Put it back to Timer blue, and then 1, 2. Okay, 2 drops. What's this color?
That would be orange.
Yes, it's orange. Like the annoying orange. Ha ha ha. Hey, apple. So you see, and just keep on doing this with different buffer pH. It's not too hard, right? Yeah, and then you give different colors here. Okay, and after that, just make sure you have clean test tubes and repeat the process for other indicators. Very simple, yeah? I wish you good luck. Have a rainbow. Bye.
Okay, so Funman is now at a conference, so
Pause the video. Instantly, I'm not in frame. I set up the tripod wrong. Fuck's sake.
I'm kind of left to my own devices, and I'm going to continue showing you guys on how to do this experiment. So we're going to be needing to make 2 things. We're going to be needing to make the blood solution and the water solution. So this is going to hopefully be representing what our blood in our actual body is, and this is going to, the water solution is going to be representing what our blood is without these two components. And these two components act as buffers, which is why when we go gym or work out and a lot of lactic acid builds up in our body, the next morning we're still fine, our pH doesn't fluctuate, is because of these two components. So that's like phosphates and kind of, well, I think they're mostly bases and acids that kind of absorb all the protons that are released by lactic acid, whereas in the water solution none of that's going to be present. So in theory, if we add a lactic acid solution, the pH will fluctuate, whereas in our blood solution the pH will remain kind of level. So that's hopefully what we're going to be showing. So the first thing we're going to have to do is make the blood solution and then make the water solution. So I'll get going on that and I'll record snippets of the process, and yeah, I'll bring you guys through it. I'm left to my own devices, so I think I'm doing this right.
I say as half my head is cut off.
Okay, so the first thing I'll be doing is I'll be making the blood solution. Now, to make the blood solution, it says on our page exactly what we need. So we need 2 milliliters of Na2HPO4 and we need 24 milliliters of NaHCO3. So we're going to take our 100 milliliters volumetric flask, which is this one here. I didn't know that, but now I do. And we're going to bring it over to our station. Also, now that I'm thinking about it, I also recommend using a funnel. So we're going to take our funnel and we're also going to bring it over here. Perfect. So it should be set up like here first. So first things first, we're going to need 24 milliliters of sodium bicarbonate. So on the day, your lab demonstrator should set that up to approximately, I think it's either going to be set up to 24 milliliters or it's going to be set up to 8 milliliters, because 8 times 3 is 24. So in our case, it's set up to 8 milliliters. So we're going to be taking this and we're going to be going 1, 2, 3. And that is going to be 24 milliliters of sodium bicarbonate. Now, we also need 2 milliliters of sodium phosphate. So we're going to bring it over to sodium phosphate. And it's set up to exactly 2 milliliters. Let me zoom in for you guys. There we go. It's exactly 2 milliliters. So now we're going to be taking it and gently 2 milliliters. There we go. There's everything we need for our blood solution at the moment. We're now going to move back to our desk and we're going to continue forward. So if you can see here, it says make each solution up to a volume of around 75 milliliters with water. But for any mathematicians doing this module, if you add 2 plus 24 plus 2, that's 28 plus 75. That's going to be over 100 milliliters, even though it wants you to have each solution up to 100 milliliters. So in order for us to get each solution to be up to 100 milliliters, we're going to have to, instead of using 75 milliliters of water for the blood solution, we're going to be using around 60 milliliters of water.
Okay, I'm gonna stop the yapping here for a little bit. This pre-lab video is already getting slightly too long, so I'm gonna give you exact bullet points of what you have to do after you measure out your sodium phosphate and sodium bicarbonate. Okay, the first thing you want to do is adjust the pH to around 7.42 using small drops of hydrochloric acid and NaOH. Quick note, make sure to use small drops. What I found doing this experiment is even adding 2 drops instead of 1 can make a massive difference in pH on the pH meter. Next, you're going to top up with distilled water to around 100 milliliters. Then add your indicator. Congo red is what's specified in the lab manual, but I think I was talking to one of the lab demonstrators and they said they're going to be using a different indicator, so whichever one they specify. Okay, you're then going to split each solution into 3 times 25 milliliter portions. So you're going to have 3 blood solution portions and you're going to have 3 water solution portions. Okay, you're then going to be adding 1 milliliter of lactic acid into the 1 of the 25 milliliters of blood solution and 1 of the 25 milliliters of water solution. Compare the results, so record the new pH of that solution and record the new color. Carry out the same process using different volumes of lactic acid and write down all your results into the table in the lab manual. Your expected results should be as follows. So for the water, the pH should drop a lot and the color should change strongly. And for the blood, the pH should drop only slightly and the color should be mostly stable. And this is a reflection of what happens in our biological systems. Hopefully you found this extra pre-lab videos kind of helpful. There's going to be bloopers possibly on Brightspace because this was my first time recording pre-lab videos. So let's just say they didn't go according to plan all the time. But yeah, hopefully you found this helpful and good luck in your labs.